So let's begin. So welcome to this webinar. This webinar is on SOLIDWORKS, the Certified SOLIDWORKS Associate exam. We're going to go through a bunch of content, but also go through the practice exam itself to kind of show some tips and tricks. So to start off this webinar, it's best to view this in full screen. If you have any questions throughout the entire time, we have multiple colleagues on the call that can answer them in the chat or in the questions area. So please feel free to ask questions at any point. And this will be recorded and we will post it afterwards. So stay tuned. Afterwards, we'll be sending out a recording. So to talk about today, I'll be your host and one of your main presenters, Ryan Kohler. I'm on the SOLIDWORKS EDU team for Industry Process Expert Specialist. And we also have Dan. Dan, if you want to introduce yourself, feel free.
Yeah, absolutely. Thanks, Ryan. So I'm Dan Wagner. I'm the manager of the SolidWorks User Group Network here at SolidWorks, and I'll tell everybody a little bit about what that is here in just a moment.
Awesome. Perfect. Let's dive in. Let's talk about what we're going to go through today. So today we are going to go through some classroom ready resources just to kind of point out a lot of the information that we did in our previous webinar, just so you're aware of the resources that you have. Dan's going to hop in and talk a little bit about the SWGN organization and different things that they do. And then we're going to jump into the majority of the content, which is going to be going through the CSWA and going through some more tips and tricks, which we started to last webinar, and we're going to go through majority of it today. So to start off, let's talk about CSWA prep resources. Many of you might have saw, but we actually have quite a few different types of content for preparing for the associate level exam, as well as just preparing for anything when it comes to learning for SOLIDWORKS. Most of this content is on solidworks.com/curriculum. And to break it down, like the specific ones that are really beneficial for the associate level exam, we have over 250 practice problems listed on that website, which go through 10 different levels of content. We basically broke the exam into 10 different levels of different varying contents from, sketches to extrudes to lofts, you name it. Then we have the step-by-step, which takes the first 4 problems for each one of those levels and actually creates an individual step-by-step document that goes through short videos and text, as well as, if you prefer, a YouTube style format where you can just go through a solution video and even has closed captioning as well as audio included. We then also have on my.solidworks.com CSWA prep course, which has 44 different individual videos going through the individual features that you need to know in order to prepare for this exam. And finally, there is also a practice exam, which we will go through. That is pretty intense with regards to capabilities. If you can make it through this exam in the time frame suggested, you're pretty good to go for the exam. Finally, in the bottom there, if you want to take a screenshot, we will send it out afterwards, but that's the link to the previous webinar where we went through this content in more detail. Now, all of this content is free. So all you have to do is log in and get access. The CSWA exam prep course, the one with the 44 videos, that one you do need to register your student serial number. So if you take your student serial number that starts with 9020 that you get from the school, you can actually register that in My SolidWorks to get access to significantly more content. And then finally, which some people have been asking for, there will be CSWP content coming soon for more practice problems, as well as we will be creating a full step-by-step learning path as well. So think about, levels 1 to 10 is the CSWA, and then levels 11 through 18 will likely be for the CSWP. So we're going to continuously create more and more content for you. All right, enough about the resources. Dan, if you want to steal the screen and tell us a little bit more about SWGN.
Yeah, for sure. This is so exciting too, Ryan. You guys have such a great crowd of students here joining today, educators as well. And I'm sure a lot of you remember too those moments when you were getting ready to prep for the CSWA exam and what that felt like. And yeah, it's exciting to see so many people here kind of getting ready for that today. So I'll share my screen as well here. So prior to this role, I'm again, as we kind of mentioned in the beginning, I'm managing something here at SolidWorks called the SolidWorks User Group Network. And just in case you're not familiar with what that is, I'll tell you about what that is here in just a moment. But before this, in a previous life, I spent about 13 years at a SolidWorks reseller teaching SolidWorks and doing SolidWorks tech support. So again, I remember those moments, and I was fortunate enough to go through that process with so many people of prepping for CSWA, CSWP, getting into the specialty exams, and hoping one day to pass the CSWE exam. And again, it's awesome, Ryan, to see this crowd you guys have and know that people are still so excited about that and looking to advance their SolidWorks skills. So beyond this, beyond taking CSWA and prepping for exams, there's a lot of other resources that you can tap into from us, from SolidWorks. And one of those is the SolidWorks User Group Network. And that's my whole role here at SolidWorks, is to manage this and really enable the leaders who lead these groups around the world, enable them to connect with as many people as possible. This picture you're seeing on the far left is a lot of our leaders gathering at a summit that we have at 3D Experience World, which is our biggest yearly event. And we get them together to talk about the year, talk about how they individually lead their groups, what resources they need, and how we can help them to be successful. Every single one of these people is basically a volunteer that leads it's almost like a SolidWorks social club. People get together to talk about SolidWorks, to share tips and tricks, to network and meet other SolidWorks users. And they do that in every corner of the globe. We have leaders from all over the place. And the whole purpose of these groups, again, is to learn and grow, connect and collaborate, and get inspired by what other people are doing and how they're using SolidWorks. And new this year, really exciting this year, is we relaunched Swugin on a new site. It's the swugin.org is our brand new site. I'll pull that over here kind of live so everybody can see it. And this is powered by a vendor called Bevy, where we now have almost every group and event under one roof here. So even on your end, just visiting swugin.org will land you on this very same website. And you can browse and see all events and all groups grouped by region across the world. So just as an example, I'll pick on the West Michigan Lakeshore Summit here that we're kind of highlighting right on the homepage. This is a major event that we have coming up in just 2 weeks. It's actually 2 weeks from today, where we get about 100 people together in West Michigan for a full day technical summit. It's kind of like a single day 3D Experience World. Really exciting, a lot of sessions to choose from. And here on this site, on this new website, you can join this West Michigan group, and then you can go ahead and RSVP for that particular event. And of course, this is an in-person event. We will be live streaming this event to our YouTube channel. But if you visit the homepage, we also have a lot of virtual events. So upcoming events, I can sort down by what is a virtual event that I could attend anywhere. And sure enough, I'm presented with a lot of different options from around the world of groups that are holding virtual events. So virtual, physical, and then big kind of co-hosted events here from SolidWorks will all be present on this website. So this is totally free. As Ryan pointed out in the beginning, right? This content today, the CSWA content you're seeing is free. And every single user group meeting is also free for you to join and be a part of. The final thing I'll kind of highlight here is on my next slide here. I kind of have a kind of an ominous picture of a dinosaur, but as part of a large event that we just did last month, we designed a dinosaur in our cloud tools, which is pretty crazy. This was mostly done in the cloud version of our tools called XDesign. And in this video, in this live stream, we did this real time, designed a dinosaur, and then showed the process for how we physically built this thing in real life. It was crazy. So maybe I'll share that link in the chat here once we wrap up, but you can find this directly on the SolidWorks YouTube channel as well. If you want to go view this and check it out, several thousand people have already seen this live stream. This is an example of if you join the user group network, you're not only seeing individual events from small groups around the world, virtual meetings, but you also have a chance to take part in some of these really large events with crazy data sets and insane builds. If you go ahead and watch this whole process, It was pretty wild. So, Ryan, I could talk all day about Swuggen, but I'll stop myself there before I go any further. But I encourage everybody take advantage of this resource, swuggen.org. You can join for free. Find the group near you, and if you ever need anything, reach out to me. You can find me on LinkedIn and all sorts of other platforms as well.
Dan, thank you so much. I really appreciate you going through all that. And actually, I'll be joining you guys out there in Michigan as well. We have a few of the education group coming to join that event, which we're super excited for. All right, let me steal the screen real quick from you. We'll go through some
Yep.
final stuff before we hop in. Yeah, and once again, Dan, thank you so much. And if
Yeah,
anybody
cool.
has
Thanks,
any
everybody.
questions, yeah, and Dan, I know you gotta jump too, but if anybody has any questions about Swaggins, please feel free to ask them in the questions area, and we will get back to you.
Cool. Now, I will hang out here for a few minutes as well. Make sure I can answer any questions.
Love that. We always want people hanging out here. All right, so let's jump into the next topic, which is CSWA tips and tricks. So what we're going to go through here is I want to talk a little bit about the exam and the layout and information about it first, and then we're going to jump in and actually start setting up the practice problem and going through the content. So if you've done the practice problem before, don't worry. We're going to go through some different ways to do different things, some speed stuff, some ways to save some time, and it should be pretty helpful. So first of all, the exam layout. It's a 3-hour exam for those who have taken it or those who have heard it before. It is not an education exam to be fair. It is a commercial exam that, like all the exams we have, that we basically give to education to use as part of the package that we offer. It's a 70% to pass. And just so you know, it's around a 60% pass rate. So it definitely differs between different age levels. But we've had 10-year-olds pass the exam, but I've also had, older people, even I know that are in industry that have a difficult time with the exam. So just because we have a wide range of people that have passed doesn't mean that it's not easy or not difficult. So we go through this content. There's going to be a few questions on drafting competencies. These are going to be some questions basically asking you about, which view this is when it comes to drafting and drawings. And then it gets into the meat of the actual exam where it's part modeling and modification. So in this, you're going to have a basic problem, an intermediate, and advanced. And those parts are going to have you model something. And then you're going to have to make a modification to it and then work on the next thing. And then next section is going to be assembly and modifications, where you're going to assemble a part like you see in the part 3 on the right there. And you're then going to basically make a modification to different things to actually design it. Now, I'm going to go through a lot of tips and tricks live while we're going through, and I'll try to repeat them so everybody can take some notes. But something that's going to help a lot is when we're going through the actual problem and you're preparing for the exam, it's good to set the problem up in a certain way. And this is going to save you time and make sure you don't have to go back and change things. So the first thing, which is the most important thing, is units. So you always want to set the units first. The problem's going to tell you what units you need, and you want to set that up right away. The next thing you want to do is material. Material is important because most of the exam is going to ask you questions based on the mass of the part or the center of mass. So it's important for you to make sure you have the right material with the right density so that you're good. Now, some people might ask, what if I have an older version of SOLIDWORKS? Don't worry. I think I think we have on the site, I think if it's 2010 or higher, you're going to be fine. So even if you have an older version of SOLIDWORKS, it won't be an issue. You'll be all set. The biggest thing to look for is look for the density of the material on there. If it matches the density of the material on the exam, then you should have no issues. Next is global variables. It's going to give you a variety of A, B, C, D dimensions, and there's a good chance they're going to tell you to change those. So in order to prepare for that, global variables are going to save you a ton of time. If you've ever used equations before inside SOLIDWORKS, or even if you haven't, you can set up global variables and basically make them the certain value and easily modify those. And then finally is origin. If they tell you a specific origin, then you need to put it in. If they don't tell you a specific one, then it's not going to likely matter for the problem, and you're going to probably focus on the mass. So make sure we're gonna go through these 4 steps when we set the problem up, but these are going to help you significantly when it comes saving time and comes to modifying the part. So let me pause the screen real quick. What I want to do is I want to switch and I'm going to change my share to jump into SOLIDWORks. And let's see. Perfect. All right. So we're going to jump into SOLIDWORks and we're going to go through the exam. We're going to set everything up and go through this live together. So this is where we're going to actually do the exam or the practice exam. So to start off, and apologies, I need to close a few things in the bottom. To start off in the practice exam, it goes through a lot of content, what you need to know, and a bunch of information. As we mentioned, all this stuff is also in our learning content, so it goes through everything you need to know. Now, when it comes to the actual exam, if we get down to the first problems, which start on page 16, you're going to go through some examples of drafting competencies. So in this one, for example, we're going to say, what type of view is this? To create the view B, it is necessary to sketch the spline as shown and draw on view A and insert which SOLIDWORKS view type. So for this one, if you've never done it, just so you know, there are answers at the bottom of it, but this one is actually A, or sorry, B, which is the crop view. So whenever you do a crop view, you can also use a spline to do that as well. When we go to this next one, to create the drawing in view B, it's necessary to sketch the spline as shown and draw an A. Which view is this? And this one, on this one, because we're cutting off a corner here, this one is C, which is broken out section. Now, inside SOLIDWORKS, there is help tutorials on the question mark where you can go in and basically do tutorials on drawings and advanced drawings. I highly suggest going through those. Those are going to help you a lot when it comes to preparing for the drawing section because it'll go through each view type so you can isolate and understand which one's which. Now, as we move forward, we're going to get to this problem. Now, for many, this looks like a pretty advanced problem if you've never actually done the exam before or never prepared for it. And yes, it is. This sketch is pretty complex for what you would need to do for the CSWA. But what the beauty of this is it actually is preparing you for probably what you would see on the exam, but also I wouldn't see too many things more difficult than this level sketch. Now, obviously, when you get to the professional level exam, that's going to change, but let's talk about this quickly. So I'm just going to extend this a little bigger so we can take a look at it. So on this part here, let's talk about the part and then we'll actually go in and set up the problem. So we have a few things here. We have the variables of A, B, and C. You can see A, B, and C. So we know we're going to have to do global variables. We can see here that this is likely done on the front plane when we're working in SOLIDWORKS. And then we can also see here that there's a variety of different dimension types. So we have a few dimensions of just height. We have a few angles. We have dimensions between specific points. And we even have some on this one, which I can see here, where the center point of the arc is actually on the line and it's a specific height. Now, something that people do get confused by, this tangency symbol is pointing to two different things between this line and this arc. And then this one down here is saying that there's two different tangencies between these two arcs and this arc and this line. So those are the type of information we need to identify when working on the part. Now, there is a few things that we can do to make this easier. Technically speaking, we can actually box this whole thing in, and we can use that as reference geometry to make this part and do it a little bit faster. So what we're going to do is we're going to look at the actual question first, and we're going to go through the steps to basically set this problem up. So part 3 here, first thing we're going to do is unit system. So if let's open a new file, a new part, and let's first prepare the unit system. So in this case, I got in the bottom right here, I'm going to set my unit to MMGS because that's what they're asking for. And then I'm going to go to the material properties. If I right click on material and go to edit material, now this one says AISI 1020 steel. So I know it's a steel, and I'll see here there's AISI 1020, but there's also AISI 1020 steel cold rolled. So I have to take a look at the density. So this is 0.0079 grams per millimeter cubed. If I look at cold rolled, this is 7870. And if I look at AISI 1020, it's 7900. So this is the one we want. because this one's, if you do the conversion, that's the appropriate one. So we apply that material and then we close. Now what we want to do is we want to go to equations. Now, if you've never gone to equations before, the easiest way to do it is to go to tools and then scroll down to equations. Or if you want, you can actually just right click on equations on the feature manager and go to manage equations. So what we want to do here is we actually want to add those variables. So we have A, which is equal to 81. And for those who use Excel, you can actually just press tab to go to the next cell. So if you like using the tab function on the keyboard to go to the next area, just like you would inside normal Excel, you can do the same thing. Now, for those who have also used equations before, you'll notice I'm not putting units on it. Technically speaking, we have the ability to add the actual unit type specifically to this, but I'm not going to for this case. If you'd like to, you're more than happy to. Once we have those set, we're going to press OK. And the nice thing is now we can actually see those in a drop down underneath the equations. So from here, the final thing we want to do is look at the part and see if they point out an origin. Remember, those are our 4 steps: units, material, global variables, and then finally origin. So they're not specifying an origin on this part, so I'm not going to worry about that. It's likely going to be a question asking, and we can see here, it's asking what is the overall mass. So we're not worried about the center of mass in this case, so we don't have to worry about the origin. Now, for me, I always like to snap to the primary planes. So what I'm going to do is I'm first actually going to save the part. Always an important step. And I'm just going to save it. Let's save it on my desktop. I'll go here, save it there. And now I'm going to start working. Obviously, saving is extremely important, but now that I have everything set up, if I do make a mistake, I'll at least know I'm in the right units, right material, and I have my global variables set up. So if I open a sketch in the front plane by right-clicking and opening a sketch, the first thing I'm going to do is I always like adding in the first dimension to something on the object to basically get it to scale. So I'm going to start by using a rectangle. Now, I love shortcuts. So for those who don't like going up top to go click on rectangle or line or anything like that, I like using the S key. The S key is one of my favorite shortcuts. I can jump to pretty much anything I want here. And if I just start typing immediately, I can actually go find other features such as mirror and so on directly in here. Now, I have a few different types of rectangles, but normally I'm going to use a corner rectangle. And if I want to be even faster, I can actually turn rectangle on just by basically holding right click and moving. So there's this wheel called mouse gestures. If I hold down right click and I move through one of them, it'll turn it on and off. So if I'm going fast, I can just go like that and turn on rectangle and you almost can't even see anything. Now, if you do like this and you want to get a little bit more crazy with the different functionalities you can do with it, you can go to customize. And there is one specifically for mouse gestures. And you can see here, you can actually bump it up to 8 or even 12. So if you're precise enough and you get the angles right, you can have lots of functions to be able to do very quickly. And obviously for the exam, because it's a 3-hour exam, time is important. So I'm going to leave it as 4 for now, but I'm going to add a rectangle in, and then I'm going to press escape to turn off the functions. Now, many times you'll zoom in or scroll out and you might lose your part. If this ever happens to you, press the F key. The F key is zoom to fit. And I can also scroll in and out with the scroll wheel. Now, another thing too is I want to highlight this whole thing and I want to select it to basically change it to reference geometry. Some might not know this, but if you highlight from left to right or right to left, it actually changes what you select. So if I do right to left, when I highlight and try to select something, it'll only highlight things that it completely grabs. So you can see here, it grabbed the left line because I completely grabbed that line. Now, if I do the other way and I go from right to left, it'll actually select anything that it crosses. So if I just want this one line, I can just cross through it and it's going to grab it. But if I go the other way, I can only grab the things that I actually got the full thing of. So it's a nice little trick to have when you're highlighting stuff. Now, if I highlight something and I don't move my mouse right away, I'll have this little menu pop up and I can actually change it to construction geometry right there. Now what I'm going to do is I'm actually going to start adding those dimensions. In this case, I'm going to add dimension of A and I'm going to add dimension of B. So if I turn on smart dimensions, I'm just going to go down here and I'm going to add a dimension, but I'm going to press the equal sign. Just like in Excel or using other software, if you type in equals, it's going to start an equation. And you'll see there's global variables and you'll see we have one called A. Now I'll press check and check again one more time. And then I'll do a smart dimension on this side for B. Now, if you don't like going down to global variables and over and you like typing, you can add quotations around B. And that actually links it to a global variable. If you just type B, it will give it the proper height, but it won't actually link it to it. So you have to add quotations around the B in order for it to actually link to the actual dimension. So now I have my frame around this part, and now it's easier for me to kind of add stuff in. So what I like to do is I like to start, somewhere along the edge and basically just start adding in the lines to how they look on the actual part. And I kind of model the part first and then I add dimensions after. Now you might notice that there's an angle line here and then there's an arc. Well, there is a trick if I'm clicking and letting go. So I don't have my hand on the mouse right now. I'm not clicking and dragging. If I move away from the endpoint I just placed and go back to it, it'll actually automatically add a tangent arc, which is really nice. And then it actually goes back to the line function right after. So this is a great way to add arcs quickly. And we're going to keep going through. Now at this point, I do want a different type of arc. So I'm actually going to press escape and go to the S key and just click on 3-point arc. Now a little trick with arcs. If you're trying to choose where you want the center point, it's easier to do it when you move to the middle of the arc. So you can see here I can move that center point a little bit easier. So I'm going to kind of put it right there just so it's a little bit close to this line because you can see here we know eventually we want to put that on the line. And then I'm going to do another 3-point arc and I'm just going to exaggerate it a little bit just because it's going to be easier to work with if I exaggerate it. Now once again, if we like shortcuts, you can press the L key and that actually turns line back on. So this is a rough shape of what we have. And it's very easy to kind of move things around, change where they are, kind of make it look a little bit more like what you want before you actually start adding dimensions. So don't be afraid to kind of move parts around where you want them before you start adding dimensions to the part. Now, there are a few things we want to add, as we mentioned, the tangencies. The tangency up top here, which you can see we have a relation already put with the tangency. And then we have two tangencies down here on these. This arc and this arc are tangent, and this arc and this line are tangent. Now, for those who've done relations before, you can click up top here to add relation, and then you have the ability to select the ones you want. Or, to save some time, if you hold down Control, click the two things you want, and let go of Control without moving your mouse, it'll actually pop up right next to your mouse. And I can click Tangent. And another trick, if you want tangencies, all you actually have to do is click the point between the two things you want tangent, and you can actually click Tangent. So whenever I add the relations between different segments or different entities on the sketch, it's easy for me to click down Control, click the point, click the line, let go of Control, and then I'll have my options right next to my mouse. Normally, the less amount of mouse movement you make, the faster you're modeling. Now, it's not guaranteed true, but if I'm not going up top every time to select something, I'm likely saving time. So in this one on this side, we actually want to not make sure it's a midpoint, we want to make sure it's coincident. The midpoint is actually very close to where it's supposed to be, but it's not on the midpoint. And that's a common issue that happens. Sometimes when you click too close, it actually selects the midpoint for you. So you want to make sure you don't select that. Now, if we add one more circle here, just so we have that guy in there, let's go around and start adding some dimensions. So I'll turn on Smart Dimensions. I'm going to start on the left side here. I'm going to add this height of 32. I'm going to make this a 45-degree angle here. I'm going to make this a height of 7. And another note for you, whenever you're working with a line that's on an angle that's not snapped to the horizontal or the vertical, technically it's a triangle. There's actually 3 different angles you can snap to. There's the hypotenuse, which is the width of the line, and then there's the vertical height and then the horizontal length. So make sure that you snap to the right one. Sometimes it's a very shallow. You might not snap to the appropriate one. So please make sure of that. Let's add 7 here. And once again, we'll do 45 here. And then we're going to add another one, which is 14 to outside here. Angle here of 10. And also with angles, it'll snap between 3 different angles between the 2 lines. If you want to get this acute angle here, the further you move out, the easier it is to select. We'll do arc here, 19. We'll do from this point to this edge of 29. Another 45 here. And because it's 45, we're not worried which one it is because it'll add up to 90 anyways. You get a height of 24 between this point and this line here. The height from this point here to the bottom edge is going to be 19. And then this point, or technically that line, but the width of it is going to be 29. Now here it might mess up, which is fine. I'm just going to press escape once and I'm just going to move this over. And you see this guy got shrunk. Let's move this over. There we go. So you just move things really easily and then all of a sudden you're good. Smart dimensions turn back on. 29, 5. And then finally the height from here to the bottom edge of that square we put on, another cube, 19. And then the final ones where we add from the center point of this circle to the outside edge of 14. And then also from the center point to the bottom edge is also 14. And then it has a diameter of 14. And you'll see here we're fully defined. So before we move on, we always want to make sure that this part is fully defined. And one key thing, you never want to see any type of relation like an anchor. For those who know what the anchor is basically locking that thing in place. And we want to avoid that at all costs. You also do need to be careful. Sometimes there might be a relation added to things by accident. So for example, if I was adding this line in here, I'm just going to redo it here just to show you. When I'm adding this line, you might notice, or when you first are making it, it'll actually try to sometimes link to the perpendicular of the line over here. So keep an eye out. If something's not allowing you to fully define the part as you add all these dimensions, the exam is going to give you all the dimensions you need. So if it's not allowing you to, there's a good chance it's snapped to something on one of these relations. So take a look through each relation and see what it's there for. But we're fully defined on this sketch. So we're going to exit the sketch. We're going to save it just to be safe. It's always good to save just in case. So I'm just going to save this PC. And then we're going to click on the sketch. We're going to extrude it. And we're going to extrude it a width of C. So once again, we're going to press equal, global variables, and go to C. And check. And save one more time. Now, when it comes to views, there are 2 specific views I like to use the most. You can go up top here or press the space bar and show this view cube where you can basically choose, isometric or normal to or front view or anything like that. I love shortcuts. I love Control-7, which is isometric. And if I click a face, I can press Control-8 and go normal to. So those are the ones that I prefer. But Control-7 for isometric is great. Let's take a look and see how we're doing so far. So let's take a look at these answers here. Which one of these answers is right? So we need to go through each one. Now, I will tell you, the first part that they're going to have you make with regards to the basic, intermediate, and advanced, before they modify it, they're going to ask you a multiple choice question, which one? Now, I highly suggest do not move on until one of these is exactly right. The reason why is if you get, let's say for some reason we think it's like we get an answer close to 577. Maybe we get 580 point something. If I then go to do the modification, the system knows what I had for an answer and how close I was. And as I do the modification, we know how much material is being removed or added. So you can get partial credit if you get the rest of it 100% right. But if you don't leave this one before you do it, like 100% right for whichever answer it is, you then it's going to be so much easier when it comes to the part modification because you're going to be more accurate with regards to the mass that you're going to have to enter. So if I go to evaluate and I go to mass properties, you'll see here I have 939.54 grams. So in this case, you'll see it's exact. So I'm going to pick D for the answer. And then now when I do my modifications, I'm likely going to be more accurate with the mass I need to enter. So let's go to the next part 4 here. And you'll see, we'll go through our steps again. Unit system the same, material the same, and then global variables, those are different. So all we need to do on this one is manage our equations, change 81 to 84, change 57 to 59, 57 to 59, and then change 43 to 45. Once we've done that, the part will automatically update. You can see how it kind of jumped a little bigger there. If you're not sure if it did or not, I would highly suggest clicking save it, and then you can hit this button here called rebuild. This is going to force SOLIDWORKS to basically go through all the different numbers and the variables, and it's going to rebuild the part from scratch. So once we've done that, we want to take a look at what is the overall mass in grams. So basically, what did it change to? And if I go to mass properties again, you'll see here I have 1032.32. Now I can tell you, because I have the answers, that is correct. So by changing those variables, we did get the right answer. Now we go on to the next step where we're going to basically do some modifications to this part. We're going to chop away a section here and here at the same exact height. You can see it's the same width through there, 19 cut, and it's a 52 away and 19 high. And then we're also going to do this arc cut, and we're going to add a hole through. So to do that, we're going to have to do a few different things. First thing we're going to do is look at the problem, millimeters, ASA 1020 steel, and then we need to change our variables. So we immediately go and we change our variables to 86. Next one to 58. And then finally, the next one to 44. Got those in there, 86, 58, 44. Okay. Let's go back to the part. Let's take a look at what we can do first. Now, depends on what you want to do, but sometimes I work on the easiest stuff first. So just a hole here. If I sketch on this surface, I could open the sketch and add the hole in, or I can just do an extrude cut. So for speed, if I actually want to do this the fastest way, I'm going to click on extruded cut, which is basically going to ask me where I want to make one. I can turn on the circle function, add a circle in, grab the center point to the top edge here and do 14, and then do center point to the left edge. Turn smart dimensions back on, 14. And then finally, we want this diameter of 10, or sorry, 11. So once we have that done, when we hit exit sketch, a little trick, it's automatically going to go to extrude cut because we selected that beforehand. Let's make sure we do through all both ways. That way, in case for some reason we modify the thickness of this part again, it'll stay a through all cut. We have that cut done. Now the next one here, which is kind of a fun one, is this arc cut, which is 12 away from the back edge. So the easiest way to do this one is to actually go through and add a plane to offset from the back surface. So I go to isometric first to make sure I'm in the right orientation. If you don't like using the mouse scroll wheel to basically rotate, for those who don't know, you can use the arrow keys to rotate as well, and it does it in segments. So I click this back surface, I can then go to Features, Reference Geometry, and click Plane. Now you can select it afterwards, that's fine. It's going the wrong direction, so we can do Flip Offset. And here we can then select we want to change this to 12. So now we have a plane offset from the back edge right there. So now if we create a sketch, we can easily cut in towards ourselves and cut out that arc right there. So let's take a look at the dimensions of that. That is a 41 around this whole thing. All right, let's open a sketch on this plane. Now it went to the opposite side, but don't worry, if you do Control 8 again, it actually switches normal to and does the other side. So you can always flip the side you're looking at depending on what you're doing. Now, to make this a little bit easier to see, I'm actually going to change it to our option here where it's just basically hidden lines removed. And what I'm going to do is I'm going to start off with a 3-point arc. Now, there's a few ways to do this. One way is to do a 3-point arc here. And you might notice that the center point of this arc is actually above the line. So I could do this and I can basically press escape. I can press control, select these two, and I can actually make this coincident, which will mean that that point, because lines are technically infinite in every direction or both directions, that it'll actually align it to that. And then all I have to do is add a smart dimension to this of 41. And then from this bottom point to the top edge of 36. Now, technically, this is enough to basically make those cuts, but for some people, they want to fully enclose this. We can convert the edges of this and then basically trim the extra. But once again, this is for speed. So you could do something like this, or we just add a spline in and we chop it away. Now, your CAD teacher might not like this, but once again, this is about speed. So the other trick though, if we want to save a little bit more time, and I'm sure there's more than one way to do this, but I want to show a few options, is I can actually add a full circle in. So if I add a circle in and I make this center point of the circle coincident with that edge, instead of doing the diameter, or the radius, I switch to diameter and I do 82, or if you're lazy, you can do 41 times 2. That works too. And now the final thing is we need to make sure that we actually get this height here from somewhere on this to the top edge. Now the trick for that is actually adding in a point. So we have an option to add a point here. And if I add a point in and I make it on this line, and then I make it on this line, that point connected to the arc and make them coincident, now I have the ability to basically make this here a height of 36. And I'm fully defined as well. So another little trick to making that cut. So now we have the cut the way we want, radius or diameter of 82 or 41, and we have height of 36, and the line is on the edge. If you don't like the way I did it with regards to this line, doing coincident, another trick would be to add a normal line in and then convert it to reference geometry and just make sure that it's vertical. That will also do the same thing. So press zoom to fit. I'm going to go to features and go right to extrude cut. I'm going to switch back to shaded with edges, and I'm going to make sure it's going the right direction, which it is. I'm going to look at the height, the distance of the cut, which is 24. I'm going to change this to blind, change this to 24, and press enter twice. Oh, let me redo that. Edit feature. Sorry, we had two directions going on there. So just blind in one direction, not two, and then do a 24 cut, and you'll have that cut nicely out there. And then finally, the next thing we need to do is we need to do these two cuts here. Let's save it real quick. Open a sketch on this surface. Now, the cool thing with SOLIDWORKS is you can also do some of this pretty easily with regards to, like, SOLIDWORKS is very smart. It can guess for you what you want. So technically, if I just put this line in and I go right here, we'll make this, I think it's 52. Technically speaking, that's all SOLIDWORKS needs to actually do a cut. So if I were to go to features here and do extrude cut, I can just basically flip the direction that it's going here. See a little arrow? I can flip the direction. I can choose the contour I want it to cut away, and then I can change this to example 19. It's 19, right? 19. And what that'll do is that'll actually just that one line, and I can cut away. Oh, that's the opposite of what we want. Flip this. Contour. Check. There we go. Sorry, apologize for that. We can cut away that very easily. And now it's easy for me to hop in and do another sketch here. Now the bottom edge, if you remember, is 19. So basically anything straight over is going to be dimensioned properly. You can see it's fully defined. If I try to add something to this, it's actually a driven dimension. So we don't have to worry about that. And if we want to be, make sure we do things right, if you're worried about cutting away nothing, you can always just add a box in here and just make sure it's bigger. Once again, CAD teacher might not like that, but sometimes it's worried about speed. And if I do the same thing and I go to features, extrude cut, same thing, down 19, press check. There we go. We have that cut out as well. Now I'm going to hide the plane because I don't want to see the visibility of it right now. So I'm going to, where's the eye symbol? Hide it. And if we take a look at this underneath our feature or our evaluate mass properties, you'll see here we have 628.18, and that is the correct answer for this one. Now we're running out of time and I want to get some time for questions. So I'm going to quickly do this next one and we can do another session, another time to go through more in assemblies. But this one's actually pretty easy. It's pretty cool. Let's take a look at this. Millimeters. We have AISA 1020 steel. Perfect. And then we have everything stayed the same. No global variable change. And this one's quick. So a lot of people think it's a shell, but it's actually two extrudes. One extrude here and then another deeper extrude. If I click on this face and I have it selected still and I do offset, I can actually change this to 1, reverse direction, and then press check. I have my sketch done already. And then all I need to do is it's 1 typical, which means it's around 1 is a dimension we use for everything. And I just need to offset from that surface. So if the sketch is still open, I go to features, extrude cut, and I switch it to, instead of blind, I do offset from surface. I can actually rotate this, select this surface, and then change this to 1. And there we go. First cut there, done. Next one's a little bit different. We have to basically do an offset from this arc here, and we have to convert this edge. So if I open a sketch on this surface, I change this to hidden lines visible. I can actually select this line, offset this in 1, press check, and then I can actually select this entire face here, and I can convert entities, which means they're on my sketch. Go normal to a control 8. And now all I need to do is basically trim off the extra. So there's a function here called power trim, which anything I go through, you can see this little gray line will actually trim off. So I go through that, outside here, all these extra ones that have been converted, and the bottom there, you'll see I'm left with just that section. So if I switch back to shaded with edges, there's my what I need to cut. Switch to features, extrude cut. In this case, I want to be offset from surface or up to surface, depending on which one I want to do. And in this case, I'll do up to surface. And I'm just going to select this surface here. So what it's going to do is going to cut down that depth, and then we're good to go. So what that looks like, if I go to my Evaluate tab and go to Mass Properties, you'll see a 432.58, and that is also the correct answer, 432.58. Now we'll stop here for now. We'll do another one of these on assemblies. Maybe next time we'll do a little bit longer. But I will talk about something really quick when it comes to tricks for assemblies. When you create certain, in this case where there's a bunch of chain links together, there is one really, really helpful trick. Once you add the mates for one of the chain links and the short pins, you can actually hold down Control, select the 2 individual components, click and drag and then let go of Control and drop them, and you'll actually duplicate the components with the actual references or the mates. So there are some really cool tricks, but once again, we'll go into that in more detail. So what I want to do now is I want to quickly talk about two more things before we hop into some questions. And for those who want to stay for a little bit longer, I have some time so we can go a little further in questions. Let me change my share screen. All right. So first, let's talk about 3D Experience World, which Dan mentioned earlier. So this year we have a event going on in Houston called 3D Experience World. For those who might have heard in the past, we used to call it SOLIDWORKS World. And we're going to be doing that from technically Sunday the 1st all the way to Wednesday the 4th. Now, this conference is designed for anybody using SOLIDWORKS, our 3D Experience platform, and it is for educators, it's for students, it's for commercial, it's for employers, designers, makers, innovators, anybody. We do tons of days of content with regards to classes and learning, where you can learn different things like PDM, or even take on the certification day on Sunday to take certifications as well. If you are a student and you want to go and you want to go for the whole time, it's only $100, but that includes over $200 worth of food. We basically include the food for you so you don't have to pay for it. If not, and you're local and you want to come just for the day to check it out, on Wednesday is our free student day. So you can come for the full day. It'll be zero cost with lunch included. And we're going to be doing a bunch of different things. We always do general sessions every day where we basically talk about all the new things that are coming and the new features and different stuff. We have reserved seating for you there. And we also have different breakout sessions for learning content. And finally, we have our playground, which is our area where all the different vendors are, where you can come and talk to different companies and work with and get more information. So you can register for this via email, solidworks.com, solidworks.edu at 3ds.com to request instructions. But we would love to see you there. We have a ton of content that we think would be really helpful for education and students as well. Finally, we do want to talk about the Skillforce program. This program is allowing for interns at companies that are registered in school to basically get access to a free version of SOLIDWORKS Premium with all the different CAD tools that come with it. This is something that, and as well as the access to free certification for CSWA. This is eligible for any student above the age of 18 that is currently enrolled in school undergrad program or any type of higher ed level program. And you'll get a license at the company for 3 to 6 months for the internship. So this saves the company a lot of money, but it also helps you out because then you're working with software that is not watermarked. That's all for the content for this webinar. We appreciate you joining and we look forward to seeing you next time.